In this lesson, we are going to see what is self-join. A self-join is like any other join, but the table is joined with its own self. Here the left table is table 1 and the right table is also table 1. In self-join, it is important to use alias name for the tables. It is useful for querying hierarchical data or comparing rows inside the same database. We will explore some examples which will make the concept more clear. Suppose this is our data set. We are using this small table to understand the concept of hierarchy. So, this data pertains to geographic areas that could be part of a very simple map database. It has 3 columns: ID, area type and parent ID along with 4 rows over here. So ID 1 has area type city and parent ID 2. ID 2 has state and parent ID 3. ID 3 has country and parent ID 4. Similarly, ID 4 is continent and parent ID is 5. So what is our problem? The problem that we are stating is, how can we fetch the child category names of area type along with their parent types? So how can we solve this? Well, we have only one data table with us. So let's perform a self-join. We need to get all the records of name of child area types and parent area types. I want each of the 4 area types basically. Okay. Consider this as the left table data and the parent name, consider this as the right data. So I suppose we can perform a left join to get the specified columns. This is to ensure that city, state and country along with continent shows up in a final output. In the output, we have 2 columns. Already it is present on the screen, right? So I have already copied over the child area types. Take a moment to fill in the output names of the parent area types. Alright, I hope you got it right. This is quite straightforward. We see that city has parent ID of 2, which area type has ID 2, that is state, right? Hence, state is the output in the parent column. Okay. So what we are doing is that the child area, which is city over here, it has a parent ID 2. And now parent ID's actual ID is what? That is over here. That means state is the parent for city. Similarly, if you look for state, what is the parent ID? Parent ID is 3. Now where we have the same ID, we have same ID for country, which says that country is the parent for state, right? And similarly, if you see, we have for continent as well. For country, the parent ID is 4 and 4 is the ID for area type continent. That's why we are having country as the child and continent as the parent ID for that or the parent for that. Whereas for continent, the parent ID is 5. In our left table, we don't have any row which is having a ID of 5. That's why, since there is no match, continent doesn't have a parent and it is filled with null. So now let's see the code to solve this problem in SQL. Here is the code. Select C.area type as child, P.area type as parent. If you see, both the column names that we are picking up is same, that is area type. From geographic areas as C, geographic area is the table which we have aliased as C. Left join geographic areas. Again, I am joining it with the same table, that is geographic area, but aliasing it with a different name as P. On which column? I want to take parent ID from the child table, that is the geographic area aliased as C, and from there we want to join it with a geographic area table which is a parent table aliased as P. But the column that we would be joining is the ID column from the parent table. Okay, so that's why on C.parent ID is equals to P.id. So this is very simple code. We have already seen that. Now the only thing is that table remains only one. So wonderful. Let's now see the output on Metabase. As usual, let's first have a look at geographic area table. Let's execute it. And here we have 4 rows as we have seen just few moments back with ID, area type and parent ID column. It has 3 columns and 4 rows. If you see, the parent ID of city is actually the ID for state. It means state is the parent for area type city. Okay, let's try to achieve this only. What we are trying to find is fetch child category names of area type along with their parent types, right? This is what we are trying to achieve. Let's write it. Select c dot area underscore type as child. I'm naming this column as child, comma, p dot area underscore type as parent, right? From which table? We require this from geographical table, geographical areas. So geographic areas table, and we will alias it as C, making this as the child table. Now what we will do? We will do a left join. Left join with which table? Again the same table, but now this time we will alias it as P so that it behaves as a parent table. Join on which column? Parent ID column of child table with the ID column of parent table. That is C dot parent ID equal to P dot just ID, right? Let's execute this. And this is the output that we have seen just now, where city is your child and we saw that its parent ID was 2 and 2 was the ID for area type state. It means state is parent for city. Similarly, for state, we have parent as country. For country, we have parent as continent. Whereas for continent, which was having parent ID 5, over there, we were not having any matching ID. That's why we don't have any parent for continent and it is null. Okay, so let's try another data table now. This data refers to the list of research students in a science lab and their lab partners. A partner means a student working together for an assignment. The columns that you see over here, the unique ID, that is the ID column over here, a student name, their partner's ID, start date and end date for the research article they have worked on. Start date indicates the day when they started working on it and end date refers to the day when they submitted it or published it. And now the problem is fetch the records of student names and the name of their associated partners. We can solve this similarly as before, but this time around, I want to use an inner join. Instead of left join, we want to make a use of inner join. This is just to show you an example to get matching records for student and partner data, even though for sake of a problem, even left join will work. Can you figure out the output? I've written already the student's name, okay? But what are their partner's name? Pause the video, then proceed once you're done writing it on your own. So, here's the output. Hope you could correctly figure it out. How did we get it? Once again, it's quite straightforward. Our first student name is Eric Jones. Eric Jones' partner ID is 3. So, let's match this with the ID column that is present in the same table. Who has the ID column? Which student has the ID as 3? That is Rani Singh, which means that Rani Singh is partner of Eric Jones. Similarly, for Dan Smith, what is the partner ID? Partner ID is 4. So, 4 is the ID for which student? Rita Paul. That's why Rita Paul is partner for student Dan Smith. And similarly, for Rani Singh, partner ID is 1. And whose ID is 1? Eric Jones. So, Eric Jones is partner of Rani Singh. And similarly, we have for Rita Paul also. Partner ID is 2. Which student's ID is 2? That is Dan Smith. So, Rita Paul's partner is Dan Smith. Let's see this code. It says select S dot student name as a student, P dot student name as partner. From lab partners as S, inner join lab partners as P on S dot partner ID is equals to P dot ID. Okay. So what we are doing, first of all, we are taking only one table, that is lab partners table. But we want to join this table with its own self. There are no two tables. Both the tables are the same table, but the alias name is different. First, we are using lab partners as S, means making it as the student table. First time. Then when I'm inner joining it, lab partners as P, this is your partners table. But if you see, the table name is same, that is lab partners. Just with alias name, we are trying to create a virtual two table presence over here. From these tables, we are picking up S dot student name as student and P dot student name as partner. Now joining on which I am taking the partner ID from the student table and checking with the ID column of the partner table. That's why on S dot partner ID is equals to P dot partner ID. Great. Let's now see the output on Metabase. Okay. So before we proceed forward, as usual, let's look at the lab partner table. So what was the code? Selects from lab underscore partners. Let's execute this. Great. We are able to get the same table that we saw just now, which says ID, student ID, what is the partner ID, start date, as well as the end date. We have 5 columns and 4 rows over here. Now let's solve a problem. What we are trying to achieve is get records of students along with associated lab partners, right? So how we will write this? And this we are trying to achieve using inner join instead of left join. So let's do this. Let's execute this. And we got the desired output. Eric Jones has partnered as Rani Singh. We saw this in the output. Dan Smith has partners Sveta Paul. Again, for Rani Singh, we have partners Eric Jones. It is just vice versa of this. And Rita Paul has partnered as Dan Smith. So let's see another problem now. What we are trying to achieve over here is find the overlapping pairs of date ranges that students spent working on their research article. Remember, start date indicates the day the student started writing a research article, and end date refers to the day they submitted it to the publisher. So here's some part of the output. Can you figure out rest according to the problem? Note that S1 underscore ID refers to the student ID. S1 start and S1 end refers to the student start and end date. Likewise, same holds for the overlapping pair column of student 2, that is S2 ID, S2 start and S2 end. So please pause and try it out on your own. Alright, here is the output. Hope you could correctly guess it. It's okay if you couldn't, as it is little bit tricky, right? No problem. Let's figure it out together. For ID1, here's the date range. What is that? 2002 November 26th, and end date is 2023 January 31st, right? Which of the other student has an overlapping date range? These all do have overlapping date range. At least some portion of the range, like some several weeks, are common between the ID1 date range. For instance, all the dates for ID2, 3 and 4 have a month of December in common, so that counts as overlapping date range with ID1. Hence, we added this as per our join data in output. So we are done with checking for ID1 overlaps. Let's check for ID2. Here are the dates, right? It is 2022 October 27 till 2023 February 1st, right? So does any user have a overlap with ID2? Yes, these do. There are certainly some dates that overlap. So why have we ignored ID1? However, since those dates also overlap, right? There is an overlap over here as well, but then how we are ignoring it? Well, since we already matched it earlier, when we checked for ID equal to 1, we already included ID equal to 2 row in the output. There is always a pair of S1 ID equal to 1 and S2 ID equal to 2 in the output. It doesn't make sense to have a duplicate row for S1 underscore ID equal to 1 and S2 underscore ID equal to 2. Again in the output, it is just waste of space, right? Hence, we have ignored it. So, we added this as per the join data in output. We are done with checking for ID2 overlaps, right? Now, let's check for ID3. Here's the date. Does any user overlap with ID3? Well, ignoring ID1 and ID2 to avoid duplicate entries, we have overlapping date range with ID4 because start date for ID3 is 2022 December 5th, whereas the end date is 2023 February 2nd. And if you see over here, we have an overlap not in the start date but in the end date over here, right? End date is also within this, as well as start date is before this date. So anyhow, your month of December as well as month of January is overlapping between ID3 and ID4. Hence, we added this as per the join data in output. So we are done with checking for ID3 overlaps. Awesome. But wait, why haven't we checked for ID4 matches? Since that was the last ID in the table? Well, if you notice, a matched observation already exists for ID4 with each of other prior IDs 1, 2 and 3. Hence, we don't need to get an overlapped row again as it would be redundant data. Fantastic. Let's see how to accomplish this through code. Don't worry, it looks daunting. It is definitely a bit lengthy query, but it's still simple to understand. Be with me, you will understand it, okay? So, what we are doing is select s1.id as s1id, s1.startDate as s1 underscore start, s1.endDate as s1 underscore end. Similarly, for s2.id as s2 underscore id, s2.startDate as s2 underscore start, s2.endDate as s2 underscore end. From lab partners S1. So first time lab partners is aliased as S1, and that's where we are picking up ID, start date and end date from S1. That is our first table, that is lab partners, aliased as S1. Inner join with lab partners, which is aliased as S2. And these three columns, which are the next three columns, we are taking from S2, that is your lab partners aliased as S2. Now, what is the joining condition? Joining condition says on s1.startDate is less than s2.endDate. Means your second table end date is greater than your first table start date. First, this condition. If end date is greater, definitely that second table thing is coming into the date range. As well as s1.endDate is greater than the s2.start date. So anyhow, we are trying to fit in S2 date range within S1 date range by these conditions. Now, one more condition we have added, that is and S1.id less than S2.id. This is used to remove the duplicates from the result. Okay. This will be clear when we see the output in the Metabase. So, what we are trying to achieve? Already we know what is the table, right? What is the table that we are seeing? That is the lab partner. We have already seen that table. So, let's directly jump to this query. What we are doing is find overlapping pairs of date ranges that students spent working on the research article. Okay, this is what we are trying to achieve. Now let's write the same code that we discussed just now. Select Okay, let's first execute this and then we will add the duplicate condition also to remove the duplicates. So if you see, we got all those over here. Now what's happening is when we have 6 columns, right? S1 ID, S1 start, S1 end, S2 ID, S2 start, and S2 end. If you see, when we have S1 ID as 4, S2 ID is 1. Similarly, S1 ID 3, then we have S2 ID 1. For 2 also, we have a matching condition. If I go to 1, 1, right? This is unnecessary. Of course, it would be in its own range. 1 ID 1 would be in its own range with 1, which doesn't make sense. The same thing has happened with everything. 1 1, and again we have a duplicate. 1 2, we already saw 2 1, 1 2, same thing. 4 3, 3 4, like that we have multiple duplicates coming over here, which we were trying to ignore before while we saw the output. How we can ignore that output is by adding this condition, and S1 dot ID is less than S2 dot ID, so that they are unique combination that we have. Let's see, 1 2 1 3 1 4, 2 3 2 4 3 4. I don't have 4 1, I don't have 1 1, I don't have 2 2. So all the duplicates have been removed.